Okay, so in this video we're going to be looking at the graph translation theorem, and in this video we're going to talk about just how to write equations knowing what a translation is. So let's start off by just talking about translations for a minute. Now if you're copying these notes down on your own notebook, I would hold off on what's highlighted here for number 1 right now, because right now we're going to focus on part 2 of this graph translation theorem, and that's to understand what a translation is. Now you might recognize that term from maybe geometry. A translation is basically a slide. It's taking a graph and moving it from one location to another. And the translation tells us specifically what's going on. So to represent a translation, we use this capital T like I have written over here. And we have H and K. H and K are going to be two numbers. Now H represents the horizontal shift, how the graph is being moved horizontally. If we move something to the right, it's going to be in the positive direction. Just like on an x-axis, to the right is positive, to the left is negative. The same thing is true for our horizontal shifting. If we move it to the right, it's going to be positive. If we move it to the left, it's going to be negative. The second number represents your k, represents the vertical shift, how the graph is being shifted up or down. If it's shifted up, it's going to be positive. If it's shifted down, it's going to be negative. Now let's look at an example so you can understand what I'm talking about here. Well, what I just graphed here is what we call a parent function. It's for the absolute value parent function, meaning all absolute value equations are based on this one here. And so that's why we call it the parent function, just like you have parents, and so you have traits that are similar to your parents, whether you like it or not. All absolute value functions are based on this parent function. And so let's say if I have shifted it, so I translate it to this new location. So let's say what I just did is I moved it over. Let me use a different color so it doesn't get confusing. Let's say if I just move this over 4 units and I moved it down 2 units. So if I wanted to represent what translation I just did here for this graph, I would say I translated it 4 units to the right and 2 units down. So I use a capital T sub 4 negative 2. So if someone looks at that, they know exactly what we've just done without even needing to see what the graph is. Now, the first part of this graph translation theorem, going back to that, this helps us figure out how we can use this information for our translation to come up with a new equation. Because let's say if I'm asked to find an equation for this purple absolute value equation I graphed here. Well, now you guys are familiar with finding equations of a line, and it hasn't always been the easiest thing to do. But with this graph translation theorem, it's going to be real easy. Because what we're going to do here is we're going to replace x with x minus h, and we're going to replace y with y minus k. And the h and the k that we're referring to are from this translation here, the h and the k. So the equation for this purple line, if I needed to come up with a new equation here, it's going to be based on the parent function, remember. So I'm going to replace the y with y minus k. Well, k in this case is a negative 2. So y minus negative 2 becomes y plus 2 equals, and the absolute value, or x is in the absolute value, so it's going to be the absolute value of, again, I'm going to replace x with x minus h. H is 4, so it's going to be x minus 4. That's in the absolute value now. So if I were to graph this equation, y plus 2 equals the absolute value of x minus 4, it would give me this graph here that I have up above there. Let's look at some other examples. Here they don't give us a graph, but they give us the translation is a negative 2, positive 4, meaning it's moving to the left 2 units and up 4 units. So to come up with my new equation, again, it's going to be based on my parent function here. So it's going to be y. We're going to replace, again, this is the key. So if you don't have this in your notes, you want to make sure you get this in there. So we're going to replace x with x minus h and y with y minus k. So my new equation is going to be y minus my k value, which is 4, so it'll be y minus 4 equals, and inside the absolute values are my x's, so it's going to be inside absolute value x minus negative 2, which becomes x plus 2. That's not too difficult. Pretty simple once you understand what this is all about. Like, let's look at this next example. It says Find an equation for the image of the graph y equals absolute value of x. So again, this is my parent function. And this is my translation, 3, negative 5. Meaning this time I'm moving the graph 3 units to the right and 5 units down. So my equation would be y minus negative 5, which becomes y plus 5, equals, and in absolute value would have x minus 3. Again, not too difficult. So let's talk about one more thing real quickly here, and that's how we can come up with the vertex form for a parabola. So for a parabola, your parent function is always y equals a times x squared. Well, if I use that graph translation theorem to come up with a new equation, I would replace y with y minus k, so it's y minus k equals instead of just y equals. And then this a we'll talk about in the next video. I'm going to replace x, though, with x minus h. So it's going to be, instead of x squared, it's going to be x minus h squared. And we're going to focus on just this first form. The other one is very similar, but what they've just done is they added k to both sides and gotten y by itself. But for the purpose of this section, we're going to focus on, like I said, this first equation, y minus k equals a times x minus h squared. So to summarize this first video here about the graph translation theorem, you want to make sure you understand that to come up with a new equation, we need to know first what the translation is, t sub h and k. Once we know what the translation is, we can replace x with x minus h, replace y with y minus k, and that'll give us our new equation. So with that, we're going to end this video talking about the graph translation theorem. In the next video, we're going to look at how to use the vertex form for a parabola to be able to graph parabolas a little easier. So go ahead and watch that next video now.